Hi, I'd be talking about our work on Phoneme-BERT, where the problem statement is how can we create a noise-robust SLU system? Typically, in any of the SLU system, the general modus operandi is to use NLP techniques applied over ASR transcripts. What happens in this process is that the errors in ASR transcripts degrade the performance of SLU systems. So to this end, we propose Phoneme-BERT, which is a joint language model over ASR transcriptions and phoneme sequences. We start with training the masked language modeling task on ASR sequences, where the pre-training step would involve predicting the mask tokens present in the ASR sequences. We extend the setup on phoneme sequences, and finally, we concatenate both sequences into a single input data point, where a joint transformer is used to predict the mask tokens from either of the sides. We hope that in this process, Phoneme-BERT, when trained jointly on ASR and phoneme sequence, would learn phoneme-specific representations as well. Results on several baselines across 4 different benchmark datasets shows that we are indeed improving over 4 to 5% across different datasets. In fact, we also apply the same technique on a real-life dataset, which is our internal sentiment classification dataset. We see that Phoneme-BERT improves 3 to 4% over the baselines of B1 and B2. The final conclusion and takeaway from this work is that Phoneme-BERT is a method that can jointly learn ASR transcripts and phoneme sequences. The pre-trained Phoneme-BERT can also be used as a word-only decoder. So in the low-resource downstream setups where phoneme sequences are not always available, we can still use the pre-trained Phoneme-BERT in absence of any of the downstream phoneme sequences. And finally, we release our generated dataset at the provided GitHub link, where datasets can be used for any of the future research purposes.